All right, let's see if we can do a little bit of work with some of these logarithms now. We're going to have a fun one today, friends. So buckle your safety belts, put your helmet on, and let's go. So first of all, can you see why these two statements are true? And maybe what we're thinking of here is if we put this in exponential form, we get b to the 0 equals 1, which is true, and a to the first power equals a, so that's kind of true. So then think for a minute, what would be the value of log of a to the x in base a? Write down a guess, and we'll see how we do. All right, well, let's do this. Let's say that this is equal to some number that we're going to call m, for example. So then if we put this in exponential form, we're going to get that a to the m is equal to a to the x. Wait a minute. So that just means that the value of m is equal to x. So what is the value of the log of a to the x in base a? It's just x. Pretty wild. So try a couple of those real quick. I'll wait for you. All right. So the first two are just right off the rule. So this first one is equal to 3. The second one's equal to 2. But let's think about the third one for a minute. Note that there's no base written down here, which implies that it's a base 10. And I can think about writing 1,000 as 10 to the third power. And again, remember, a logarithm's value is the exponent of the base that gives the number. So 10 cubed is 1,000. Can you do the same with the last one? I want to think of 49 as maybe 7 squared, and that should tip you off that it's going to be 2. Pretty cool things. That's having a good understanding of logarithms. That's what we're all about today, man. All right, let's keep going. So then what do you think the value of this would be? Play with it for a little bit. See what you can do. I'll come back in a moment. All right, why don't we proceed the same way? Let's say that this is equal to some, some number that we're going to call m. All right, so now if I rewrite this exponential in logarithmic form, I'm going to get the log of m in base a is equal to my exponent, the log of x in base a. Wait a minute, the bases are the same, so their values are the same. So what does all this equal? It means that, well, not the log, it means that a to the log of x in base a is just equal to x. Pretty neat. Try a few of these. I'll wait for you, but not too long. All right, this is just set up to scream the rule at you. So this one's just going to be 9, and this one's going to be 16. I'm just following the rule that's right above me. That as long as this base and that base are the same, the answer is that number there. Oh, I love it. Absolutely love it. All right, little graphing calculator exercise. What I want you to do is I want you to write down the decimal values that you get for these expressions. So pause the video, play with your calculator for a minute, see what you get. I'll wait for you. All right, did you notice that some of these values were the same? Like the log of 2 plus the log of 3, that was equal to the log of 6. And this had the same value as the one for the log of 15. And this was the same for the log of 20. You know what I'm going to do. What do you notice? And can you generalize it? I'm looking for something like, what happens when you take the log of, say, some value a, and you add it to the log of some value b? Can you express it in terms of a and b? Oh, sure. How about the log of ab? And hopefully that makes sense to you. Remember, we had a relationship with exponents where when you did something like x squared times x to the third, you got x to the 2 plus 3. You added your exponents. And aren't logarithms just another way to express an exponent? Oh. So then this one might be good for you as well. And maybe you think back to some of the values you got last page. Okay, give it a shot. Alrighty, did you find out that this was equal to the log of 6? And this one gave you the log of 15. And this one gave you the log of 20. All right, you know what I'm going to do. What do you notice? You notice that like 12 divided by 2 is 6, and 60 divided by 4 is 15. So if I do the log of A and I subtract the log of B, I get the log of A divided by B. And again, think about how you simplified exponents when you were dividing. You end up subtracting them. So that relationship should hold true for you. One last one to try. See if you can match these up at all. So did you find that 2 times log 5 was equal to log of 25? And 3 times log 2 was the log of 8? And 1/2 log 16 was the log of 4? What's going on? Ooh, so my question is, what do you notice? And can you generalize it? What do you think? Maybe if you're thinking like, if there's some number that you multiply by the logarithm of a number, it's equal to the logarithm of a to the power of m. That's our little power rule for logarithms. Oh, that's great stuff. So now we want to apply these rules. So let's see if we can use some of our previously learned properties to write these as a single logarithm. So I want this answer to be something like the log in base 5 of some number there. See if you can figure it out. I'll pause the video for a minute for you. Pause. All right, let's see what we got. So this is addition, and there's also like a little number in front of there. So I'm thinking that this is going to equal the log of a multiplication problem. And I'm going to multiply 6 by 2 to the 3rd. Oops, I forgot my base 5. So in terms of a single logarithm, the first one is the log of 48. And if we do the same with the second one, maybe we notice that it's going to be some division. The 1/2 becomes the exponent, and that is a square root. So I'm going to get the log of the square root of 64 over 4, all in base 3. So I'm going to get the log of 2 in base 3. Square root of 64 is 8. 8 divided by 4 is 2. What the heck's going on with this bottom left one? Oh, man. Yikes, what do I do with that 1? Well, I know that if I write this 1 as, but like that, the log is an exponent, right? So if I want base 7, what number can I put in here to give me 1? Yeah, it's got to be 7. So what I'm going to do, got a little skinny on me, let's erase that for a second. So what I'm going to do is I'm going to rewrite this as the log of 7 in base 7. Oh, that's convenient. That's sneaky. So now I get the log of 8 over 7 in base 7. And that's cool. Does that help you with the last one, maybe? Oh, and this last one, notice we're in base 10, right? So I got to think, how can I write a log in base 10 that's equal to 2? Well, it's got to be the log of 100. So when I add it to my 2 log 5, I know I got some exponent thing going on here. So I got the log of 5 squared times 100. So I'm going to get the log of 2,500 for this one. Pretty darn neat. Fun stuff there, man. Loving it. Well, let's see if we can go the other way now. Now x is equal to the log of 2 and y is equal to the log of 6, all in base 4. Can you write each of these in terms of x and y? Play with it for a minute or two, please. I hope you get ugly doing this. Not like physically ugly, obviously, but I hope that your learning gets ugly so you learn from it. Give it a shot. I'll wait. All right, so I'm looking at this 12 and I'm thinking, can I take a 2 and a 6 and make a 12? I sure can. Let's write this as the log of 2 times 6. So this means then it's the log of 2 plus the log of 6. Now, I know that x is equal to the log of 2, y is equal to the log of 6 when we're in base 4. So we're going to write this answer then as x plus y. That's all. Oh, that's what you meant. Yeah, pause the video, finish the other 3 if you haven't done so. So maybe you notice that the 3 is 6 divided by 2. So then if I write this division as a subtraction problem, the log of 6 minus the log of 2, and then it looks like I'm going to get y minus x for my answer. Neato. Oh, how do we rewrite 72 using 2's and 6's? Well, let's see. 2 times 6 is 12. 12 times 6 is 72. Oh, so I can write this then as the log of 6 squared times 2. Nice. So then if I expand it using my addition and my power rule, I'm going to get 2 log 6 plus log 2. So this is going to simplify down to 2y plus x. Wild stuff. So maybe that helps us to do this last one here. Oh, but I don't know which way I'm going with this. 32. How do I get a 32 from a 2 and a 6? Let's see. Well, I know 16 times 2 is 32. Ooh, what about this? What if I write this as the log of 16 in base 4 plus the log of 2 in base 4? Because at least I got a 2 in there. But also, let's think about that rule about what a logarithm is. A logarithm is a fancy way to say an exponent. So really, this logarithm right here is equal to 2, because 2 is the exponent for the base of 4 that gives 16. And then the log of 2 in base 4 is just x. So maybe I'll write that not as 2 plus 2, but let's write it as 2 plus x. That was nifty. Creative here. Wow. To come up with that. That's good. You need practice to do that one. Yes, yes, yes. All right, so we've been talking a lot about log, but we haven't been talking about our friend e yet. So remember, e is a base, so we don't really write log of base e. We use the natural logarithm. You've probably heard of that, the ln. But we don't write it as ln of e, we just ln of x. It's just implied that if we use ln, the base is e. So can you write down these two values? So the log of 1, So remember, let's pretend that equals some number, right? And our base is e, so e to the x is equal to 1, which means that that x value has to be 0. So that means the natural log of 1 is 0. And remember where that graph crosses the x-axis? When x is equal to 1, y is 0. Maybe that ties it into you a little bit. And how about then the natural log of e? If you want to think of this in exponential form, call that like x. So then e to the x has to equal e. So, not e, but x has to equal 1. So ln of e is just 1. So if we know that, can you write down some of these values? Pause the video and play with these for a second, friends. All right, so maybe I'm going to use some of my rules from before. I'll use my power rule, right? So I'm going to bring that exponent down. and I'm going to get 2 times the natural log of e. But I know the natural log of e is 1, so this becomes 2 times 1, which is 2. So e to the natural log, of 5. You might remember from a while ago that we had a relationship that said, if we do some base to the log of a value in that base, it just equals that. So e to the natural log of 5, ln of 5, that's just 5. Cool. Well, what if we use our subtraction division rule here? And let's say that this is going to be the log of e to the x minus y. ln of e is 1. I didn't really mean to write that as an exponent. I'm sorry. Making a mess here. Sorry about that. So it's the natural log of e to the x minus the natural log of e to the y, and that's just going to be x minus y. You want to use your little power rule and bring those down first and get it so it's like x times the natural log of e, which is 1, right? Minus y times the natural log of e. Maybe we can do that. All right, we're almost there. I told you you're gonna buckle in and do a ton of logarithms today. It's helpful at times to change the base of the logarithms. And this is a nice little way to change the base. So it goes, notice, from base A to base B. So we can substitute a new base here. So if I want to convert the log of 20 in base 3 to base 10 first, what I'll say is that the log of 20 in base 3 is going to be the log of 10. I'm sorry, the log of 20 in base 10 over the log of 3 in base 10. And back in the day when we didn't have the fancy calculators that could figure out the logarithms to any base, I remember changing the base to get it to base 10 so my calculator would do the work for me. Another reason why you guys have it so good. And if we want to change this to base e, it's going to be the same thing. But instead of using logs, let's use natural log. Natural log 20 over natural log 3. And we'll wrap this up by asking you to change some bases for me. Suppose that the log of 8 in base 5 is p, and the log of 3 in base 5 is q. Can you express in terms of p and q the log of 3 in base 8? Take a moment, see what you can do. All right, so what I know is that the log of 3 in base 8 is going to be the log of 5 of base 8, log of 8 of base 5, over log of 3 in base 5. That changes my base from base 5 to base 8. And now I just got to substitute in my values. I get a p on top, I get a q on the bottom, and that makes me happy. Boy, oh boy, everything you want to know about logarithms, but we're afraid to ask, huh? This is a big day. We need practice.